Okay, as you can see on the board, we have another set of questions. They are still under indices. After this, I'm going to discuss, or I'll be going to indicial equation, also known as exponential equation. So as you are watching the video, you can see my Twitter handle, my Facebook, my Instagram is also displaying. So you can send me questions, you can follow me on Twitter, drop your questions on my Facebook page. I will get back to you with the solution. So I'm not saying this is the question, this is the only question you have under indices. No, feel free. I'm here to solve your problem. Okay, Mass Doctor, remember the name. 9 raised to power minus 1 over 2 times 81 raised to power 3 over 4 divided by 9 raised to power 1 over 2. This is the question. Now, when you look at the base here 9, but the base here is what? 81. The power here is 2. Let me introduce another style. This denominator here, 2, is telling you that this number can be written in index form and the power will be 2. That is the 2 here. Okay, and if you check, 3 raised to power 2 is the same as 9 because it means what? 3 times 3 into bracket minus 1 over 2 times, similarly, this 4 is telling us that this 81 can be written in index form and the power is going to be 4. So we have what? 3 raised to power 4, that is 81. Again, introduce a bracket to differentiate the 81 from the power. All over, you can do the same thing to this. 9 raised to power 1 over 2, we can write what? 3 raised to power 2 for 9, okay, into bracket raised to power 1 over 2. Now, if you use the law that states that the power inside multiply the power outside, this we cancel out this we cancel out this, and this we cancel out this. Now, we are having what left here? 3 raised to power minus 1. We are having what left here? 3 raised to power 3. And for the denominator, 3 raised to power 1. The base here is 3, 3, 3. Since the base are equal, we can combine log 1 and log 2. What do? We pick one among the base. The sign here is multiplication, so we are going to add this and this. That is minus 1 plus 3. And remember, this is the same as what? Division. So we are going to minus 1. Is that clear? So 3 minus 1 plus 3 is what? 2. And 2 minus 1 will give us 1. 3 raised to power 1 is 3. So this is the answer to question A. Question B. We have 16 raised to power 3 over 4 minus 8 raised to power 1 over 3 all over 2 raised to power 2 times 3. The 4 here, as usual, let's use this method I use here. The 16 can be changed or expressed as what now? 2 raised to power 4. 2 raised to power 4 is 16 raised to power 3 over 4 minus this 3 is telling us that, okay, we can change this to index form as well. So 2 raised to power 3 raised to power 1 over 3 all over 2 raised to power 2 is 4. Then we have what? 3. Again, if the power inside multiply the power outside, this is going to cancel this. This we cancel out this. So we have what? 2 raised to power 3 minus 2 raised to power 1 all over 12. 2 raised to power 3 is 8. 2 raised to power 1 is 2 all over 12. 8 minus 2 will give us 6. And 6 divided by 12 will give us 1 over 2. We just have to reduce it to its lowest term. That is the answer to B. Question C. We have 4 times 4 raised to power minus P times 2 raised to power 2p minus 2. Since the lowest base here is 2, we are going to change this to base 2 index form. Okay, so this 4 become what? 2 raised to power 2, 4 times this 4, 2 raised to power 2. But remember, we are having a power minus p, so we have to introduce a bracket, write the minus p here, times 2 raised to power 2p minus 2. Now, we need to apply law number 7 to remove the bracket by multiplying the two powers. So that gives us 2 raised to power 2 times 2 raised to power minus 2p times 2 raised to power 2p minus 2. Now, when you look at the base, they are the same. They are all the same. So we pick one among the bases that are all the same. We add the powers together since the sign is multiplication. So that gives us 2 plus minus 2p. Differentiate the sign by introducing bracket, plus bracket open 2p. Okay, there is no sign here, so we are going to just write 2p minus 2. Now, if this multiply this, it will give us 2 raised to power 2 plus times minus is minus 2p plus 2p minus 2. And that will give us 2 raised to power 2 minus 2, because they are both constant, they are both like terms. 2 minus 2 will give us 0, and minus 2p plus 2p is also 0. So we have 2 raised to power 0. Everything here gives 0. Remember law number 3, anything raised to power 0 is what? Is 1. So the answer to this question is what? Is 1. In question D, we have what? Square root 54 y raised to power minus 4 all over 6 y raised to power minus 8. Okay, that's the question. What are we going to do here? We first remove the roots, and remember, it's going to give us, and while removing the roots, we can break this into 2. 54 over 6 times y raised to power minus 4 all over y raised to power minus 8. Then the roots become 1 over 2. 1 over 2. Is that clear? I'm applying what? Law number 5 now. I'm changing the root. Remember, there's one question I solved in example 1 that the denominator happened to be 2, and I told you we don't put the 2 here. Just have it at the back of your mind that square root means what? A 2. But if it is cube root, as in cube, fourth root, 3, 4, 5, you must put it. You must write it out. Now, 54 divided by 6 will give us 9 times, apply law of indices to this, law number 2, the division rule, the base are equal, you will pick 1. And since the sign is division, you will do what? You will subtract the powers, that is minus 4 minus minus 8. Differentiate these two, then bracket close, 1 over 2. So that gives us what now? 9 times y minus times minus is what? Is plus. So minus 4 plus 8 will give us what? Will give us 4. All raised to power 1 over 2. The 9 is the same as 3 raised to power 2 times y raised to power 4 now, all raised to power 1 over 2. Remember, there's a law that states that if you're having two powers, one inside the bracket and the other outside the bracket, we do what? The powers will multiply each other. So we have 3 raised to power 2 times 1 over 2 times y raised to power 4 times 1 over 2. This will cut out this. So we have 3 raised to power 1. 2 here 1, 2 here 2. We have what now? Times y raised to power 2. So at the end of the day, 3y squared. Answer. Question E. 2 raised to power m minus 2 raised to power m minus 1 all over 2 raised to power 3 times 2 raised to power m minus 8 times 2 raised to power m minus 1. How do we go about this? Note, since you have 2 raised to power m here, and you can also see 2 raised to power m minus 1, we are going to factorize. What is common? The highest common factor between this and this is 2 raised to power m. You open a bracket. 2 raised to power m divided by 2 raised to power m will give us 1, because anything divided by itself will give us 1. Now we want to divide this by this. Check. 2 raised to power m minus 1 divided by what? 2 raised to power m. If you apply law number 2 of indices, the base are the same, you will pick 1. And what do you do to the powers? You minus, that is m minus 1 minus m. You discover that the m minus m will give us 0. And we are going to have what? 2 raised to power minus 1. So, minus 2 raised to power minus 1. That is for the numerator. If you want to check whether we are right, multiply. Use this to open the bracket. 2 raised to power m times 1 will give us 2 raised to power m. And if you solve 2 raised to power m times 2 raised to power minus 1 using law number 1, you will end up getting 2 raised to power m minus 1. Now for the denominator, look at this and look at this. What is common? This 2 raised to power 3 is 8, just as we have 8 here. So you bring out the 2 raised to power 3 because it's common. And also, if you ignore this 2 raised to power 3 and the 8, you discover that what we have left is more or less the same thing as what we have up here. So 2 raised to power m is also common. So bracket open. If you divide all this by this, we are going to have 1 because they are exactly the same. Now, if you divide all this by this, 8 will cancel out 8 because this is 8. 2 raised to power 3 means what? 2 times 2 times 2, which is 8. They will cancel out. And again, this divided by this will leave minus 2 raised to power minus 1. This and this are exactly the same. So we can cancel out. This cancel this because they are the same. What we have inside the bracket are the same. Now, focusing on what we have left, you discover that the numerator here is 2 raised to power m all over the denominator. Here we are having what? 2 raised to power 3 times 2 raised to power m. It is allowed in mathematics. When you look at what we have here and these, they are the same. You can say 2 raised to power m divided by 2 raised to power m, 1. Then this 2 raised to power m divided by 2 raised to power m, 1. So the numerator, we are having 1 left all over 2 raised to power 3, which is 8, times 1 will give us 8. So the answer to the question is 1 over 8. Okay, the next question, as you can see on the board, is what? 3 raised to power 2k plus 1 times 9 raised to power k times 4 raised to power 2k all over 18 raised to power k times 2 raised to power k times 6 raised to power 2k. What we are going to do here is we are going to reduce or express the 9, the 4, the 18 and 6 to the lowest term, meaning 3 raised to power 2k plus 1 times, instead of writing 9, we are going to write 9 in index form, 3 raised to power 2 into bracket raised to power k times 4 is the same as what? 2 raised to power 2 into bracket 2k all over, as we all know, 18 is the same as 9 multiplied by 2 or 2 multiplied by 9. Is that okay? So this 9, if we write this 9 in index form, we are going to have 3 raised to power 2 for 9 times 2 all raised to power k. What I have here is still the same as what? 18 raised to power k, because if you simplify the bracket, 3 raised to power 2 is 9, 9 times 2, 18. So it's still the same as 18 raised to power k times 2 raised to power k times 6 is the same as 2 multiplied 3 all raised to power what? 2k. Yes, everything here is still the same as 6 raised to power 2k. Now remember, if we have brackets and there's a power inside the bracket, one outside the bracket, the powers will multiply each other. So we want to remove all the brackets. That gives us 3 raised to power 2k plus 1 times 3 raised to power 2 times k will give us 2k times 2 raised to power 2 times 2k will give us 4k all over. The power of this is 2, so the 2 multiplied k will give us 3 raised to power 2k. The power of 2 is what? 1. Remember, anything raised to power 1 remains the same. So 1 times k will give us what? 2 raised to power k. Then we have times 2 raised to power k times the power of these 2 and these 3 are both 1. So if the power inside multiply the power outside will give us 2 raised to power 1 times 2k is 2k, and 1 times 2k will give us what? 2k as well. Now we are going to look out for what we can cancel out first. For instance, 3 raised to power 2k is here, and this is another 3 raised to power 2k. They can cancel. Is that a thing? We can cancel them out. Let's bring out what we have left after the cancellation. Numerator, we have 3 raised to power 2k plus 1 times 2 raised to power 4k all over 3 raised to power 2k, okay, times the base here is 2, the base here is 2, the base here is 2. Since the base are the same, we can easily pick 1 and do what to the powers? Add the powers together, that is k plus k plus 2k. Is that okay? So that gives us 3 raised to power 2k plus 1 times 2 raised to power 4k all over 3 raised to power 2k times what? 2 raised to power k plus k is 2k. 2k plus 2k will give us 4k. So 2 raised to power 4k. When you look at this and this, they are the same. So we cancel out, they cut out. We are left with what? 3 raised to power 2k plus 1 divided by what now? 3 raised to power 2k. And I believe here we can apply law number 2, the division rule. Since the base are equal, we are going to do what? We are going to pick 1. Okay, you know, yes, 3 and this 3. We pick 1. And since the sign is division, we are going to subtract the powers. So that gives us 2k plus 1 minus 2k. 2k minus 2k will give us 0. Okay, 2k minus 2k is 0. So we have only plus 1 left, which is the same as 3 raised to power 1. Remember, anything raised to power 1 remains the same. So that gives us 3. Is that okay? Now, this brings indices to an end. As I said earlier, after solving this set of questions, I will be doing what now? Moving forward or moving ahead to what we call indicial equation, which is the same thing as exponential equation. Thank you. Stay tuned.